Okay, so let's take a look at just a couple more examples of U substitution problems that are a little bit harder. Now, for a problem like this, choosing U is a little bit tougher. Now, similar to the last one that we did. Now, some people panic. They'll say, oh, look, 2x is on the inside, so I'm going to pick 2x on the inside. And you can do it this way, but then you're going to get this. Ready? You get U equals 2x, du equals 2dx, dx equals du over 2. So when I plug it in, I get this. Sine u, cosine u, du over 2. But if you notice, I'm running into the same exact problem that I had on the last one. I can't take the antiderivative sine and cosine independently of each other like this. There's no product rule. So I have to use U substitution again. So in this case, we call it W substitution, or Wernow substitution. So again, I'm going to let W be the sine of U, and the derivative dw du, as you can see it's getting more complicated, we get the cosine of U du. I'm going to move the du over there. So solving it, I get du now equals, cosine of U, or dw, over cosine of U. And that's what I want. So when I replace it, I'm going to get the following. W times the cosine of U, du, when we replace it, I get dw over 2 cosine U. And they cancel. And what I'm left with now is this 1/2 w dw. And I can integrate this. I get 1/2. Again, put parentheses here because I put my 1/2 on the outside. W squared over 2 plus C1. And if I distribute, I get 1/4 w squared plus, be careful, remember I'm distributing to the C1 also, C2. So my final answer, 1/4, replace my w, I get sine squared of U, but U is 2x. So I go back up here to 2x plus C2. So that's one way I can solve a problem like this. I can do U substitution twice. Now another way I can do this one, a little quicker, if I get the sine of 2x, cosine of 2x, dx, whoa, focus, there we go, come on, there we go. Another way I could do this, I can let the sine of 2x be my u. So my du becomes, what's that become? Cosine of 2x times 2, dx. dx becomes du over cosine 2x times 2, and if I plug it in, I get u times the cosine of 2x, and I get du over cosine 2x times 2. Cancel, cancel. Already, you should recognize I got that 1/2 on the outside. Bring the constants out. I get u du. So I get 1/2 u squared plus, over 2 c1. And if you notice, I do get the same answer. 1/4 u squared plus c2. Don't forget you're distributing both. Or 1/4, what's u? Sine squared of 2x plus c2. So if you notice, I get the same answer, just a little quicker this way. Both methods work. Look at this. It works. It works. And that's fine. Either way's fine. But just like I said, the more you know, it'll help you. Now, the more you know, the faster these can go. Now, the last one I want to take a look at is it's U substitution's evil twin brother, algebraic substitution. Now, algebraic substitution works the same way. If I rewrite this, I'm going to x times 2x minus 3 to the 1/2 dx. I'm going to let my u be the 2x minus 3, just like we have done. Du becomes 2 dx, and our dx becomes du over 2. Replace it. I'm going to get, let me write in the black pen, x u to the 1/2 du over 2. Now here's where the evil comes into play. Look at this. Just look at this. We can't have x and u in the same place. And in this case, nothing cancels. So I'm stuck with it, but I still can't integrate it yet. So the question is, what do we do? Very simple. we know u equals 2x minus 3. Solve for x. I get u plus 3 over 2. And I'm going to substitute that in. This is called an algebraic substitution. Okay? So, when I plug it in, I'm going to get u plus 3 over 2 times u to the 1/2 du over 2. Now, everything's in terms of u. But I do have two constants here. I'm going to take them out. That becomes 1/4. And this becomes u plus 3. Whoops, I forgot my 1/2. See, the 1/2 is only... Oh, no, never mind. There's not 1/2 there. I messed up there. No 1/2 there was on the u. Sorry about that. I misread my problem. So, times u to the 1/2 du. So when I distribute this, the 1/2 u to the 3/2 plus 3u to the 1/2. Now I can take the antiderivative, and we get 1/4 times u. This becomes u to the 5/2 times 2/5 plus, be careful, u to the 3/2, and if I invert and multiply that, 3 times 2/3, 3's cancel, plus c1. And if I want to, I can distribute. I get, what's this? Those will cancel, so I get, what's that? 1/10 u to the 5/2 plus 1/2, that's a 2 there, right? U to the 3/2 plus c2. And my last step, just replace my u. Now you know I call this the evil twin brother. I mean, look how long this one took. Algebraic substitution is nice, but it is kind of a hassle. And there's our antiderivative, okay? Alright, so I'll see you guys later. Bye-bye.